Okay, so I am doing some very exciting computer programming today that I want to show everyone. And this may not seem impressive to you at first, but when you understand the complexity behind it and how long it took, then maybe you'll see why I'm excited about this. I'm going to switch to displaying my screen so you can see my source code. Okay, so I have a few things to show you. Now, first thing I want to show you is that this folder here is empty. It's my output folder, but I want to show you I'm going to do some stuff with a special bitmap font I made. Now I want to talk just a little bit about how I came up with this. Now this file here, this bitmap file, is an 8x8 pixel font. It's in my own custom format that I made. Now this particular arrangement of letters, you may not be able to see this very easily, but each of these characters, it fits within an 8x8 pixel grid. And they're aligned in a very particular way so that there are 16 characters per row. However, you may notice that, for example, the very top left is blank. That's because that's the character for a space, which is of course completely blank, because a space would just be an empty square. But all of the 26 letters, both in lowercase and capital versions, as well as the number symbols, various punctuation marks, all that sort of thing, all of these are there. This is a zoomed in image at 1000%. Of all these characters, but if we go, the characters themselves are actually very small, but you get an idea. Now that's the font. Now this, I wrote so much code tonight, so I want to show you. Now my main function of my C program, all it does is it calls BBM font test. Now this function itself calls many other functions. But first I want to show you it in action so that you can see what it does. So here I'm going to just basically go over this. We're creating a new image of size 512 by 512 pixels, but then it loads my bitmap font with another function, and then it saves that font to a file, and then it outputs a single character to my output image using that font, and then it saves that output image. So I'm just going to show you in action. So we're going to go back to the O folder, which is kind of my output folder. Now I'm going to go back to my terminal and type make. This program is going to compile and run. Now it displays several different things of text. It's loading a font. It's kind of complicated to explain it exactly, but it loads a bitmap file using another function I wrote, and it knows that the image width is 128 pixels and the height is 48 pixels, and it's loaded that image. And the size of each character is 8x8 pixels, and there's the size load image. And we're trying to output character 5 at position 100, 100. And you see that's because it's hard-coded right into here, that specific position and that character. So let's go to the output folder. We see two files. First, we see this same image. This is the exact same image I showed you earlier. It's just that it's been loaded by my program and then output into this other folder. And that was required step just so I knew that my program was loading it and saving it correctly. But then we have another image. Now this image is green, and the reason it's green is because I filled it with green right on this line. I filled that whole image with the color green. But anyway, back to this. Everything's green except for this part right here. This is where the character 5 is, and notice how it fits into that little square. That's precisely what I'm talking about. And I can change that character. So I'm going to show you I can change that character to something else. Like let's change it to capital letter R for no apparent reason. We can choose any character pretty much. And let's just recompile and rerun it. So then I'm going to load this image again, and you will see there's the letter R. It works no matter which letter or number I use for the character. Now this function only outputs a single character, but you'll notice I ran this program twice, and notice that the output's the same, except that it tells which character is trying to output. See right on this line here, it says that, and then here it's R. Now it in each case tells me the character was found in the font bitmap at the certain position, and I'm going to show you the math behind this. Most people are not going to get it, but this is all custom made by me. So we have several global variables I made. So I have variables for the width and height of a single character, and then I also have global variables that store the width and height of the font image, because we're loading a single font, so a global variable is just absolutely fine in this case. Now characters per row, we know that it's 16 because I showed you the image. There's 16 characters per row. And how does it calculate that? Well, notice that it calculates it and it says there's 16 characters per row. And that's because the image width is 128, and it divides that by 8 because there's 8, the width of a single character is 8. So, you know, a single character divided into the width of the image obviously is 16. So that's how it knows that there are 16 characters that can be in a single row, basically. But that's only because I created that image to begin with, for the characters to be at that very specific position. So let's look again at this font. Now you may be wondering, how did I come across this particular font? Well, believe it or not, this font is included with Windows. Now I don't know where the exact font file is, but I'm gonna show you exactly how I got the characters. So if we go back to my font folder here, I have several files in here, but there's a very specific file, ASCII.txt. You see this? This has all of those characters. That's where those characters are stored. But I'm going to copy the address of this folder, and I'm going to open this up in the command prompt. cd. Okay, so here's our directory. Now if I do the DOS command type ASCII.txt, well, notice that is the exact characters. Those are the characters. However, the reason those characters look that specific size is because of the font I have selected. Right here in the properties, notice that I have the raster fonts option here, and the size is 8 by 8. So if I were to choose a different one, like let's use Courier New, let's use a font size of 20. Well then, let's see here, we're going to redo the command. Well, now the characters look different because it's a different font. However, the reason that I particularly chose for the raster fonts option is because it had an option for a perfect square. See, these different options of sizes have different, like this one is 12 pixels wide and 16 pixels high, but I wanted one where it was a perfect square, 8 by 8 pixels. So that is why this particular font from the raster fonts option in the Windows command prompt was chosen. So that's basically it. So that's precisely what I did. Is I did this command in the terminal, and then I basically screenshotted it and then cropped it in GIMP. That's what I did, and that is how I got that font. It's bizarre. And of course, I purposely laid it out to be 16 characters per row. It could have been a different number of characters per row, but I like the number 16. So anyway, that's the history of where I got that font. It's included with Windows, so if you have Windows on your computer, that font already exists. So everybody has this font. It's not something special, but making the image file of it was my particular invention. So my program is meant to load that font. Now I'm going to show you. Okay, let's run this program one more time. Let's see. Well, actually, let me show you how does it load the font. First, it's called with certain numbers. Now, this function has to be called with the width and height of 8, the load font function, as I did call it that way below. That's because there's no way it can know how many characters wide and high a single character is supposed to be. That has to be passed as arguments to the load font function. That's the way it is. So I already knew it was 8 by 8 pixels because that's the way I set it up. So I passed that. So that's how it knew, and it did all that math. So it loads the font, it takes the file name passed to it, it loads that bitmap file, and then it stores the width and height passed to it into the character width and height, and then it displays that information. Basically, it always displays that. So yeah, it displays that the font was loaded and the size of each character and the size of the image. So that's what it does. So yeah, I mean, and so. But then you might be wondering, how does it know how to output a certain character? Well, let's just take some other strange random character like a lowercase z. Let's just do that. So let's compile and run it again. It's trying to output the character z. Okay, and let's see if it worked. Of course, it probably did. Yep, there's the letter z right there. So this function that outputs a single character, yeah, this function is big. It displays it's trying to output that character at that position. Now that's just text to help me diagnose this. So the character is passed, and there's the position. Now it's expected to be within a certain range. It's only meant to be from here to here, the printable ASCII characters. But I subtract 32 from it. It's 20 in hexadecimal, so that the math is simpler. So basically, a space becomes number 0 instead of being number 32, because it's at the top left. So that should be fairly straightforward if you follow the math. So then we have 4 variables here. We have x1, y1, x2, and y2. Now, this is a formula for finding the position of a certain character. So we have a certain character. In this case, it's the letter Z. So how does it find that the letter Z is at 8040? Well, let's look at this font. We already know how many characters per row there are. There's 16. It did that math for it. And it finds it way at the bottom. Now, it's basically dividing the number of rows. So I don't remember the exact number of what that is because it's all ASCII. It automatically does the conversion. But I'll just show you the formulas here. So we have the character number after it's been subtracted from, divided, and we get the remainder of division by the characters per row, which in this case is 16. So it will take that number, the remainder, which will be a number between 0 and 15, and it uses that for the x-coordinate. So it'll be 0 through 15 times 8 because it's going to have a width of 8. So font character width is 8. So it automatically knows where the x position is based on the the bottom 4 bits of that byte, and you can start to see why I made it 16. So then it gets the upper half of that byte, the multiple of 16 of it, by taking the character number, dividing it by the characters per row. So it divides it by 16. So the upper half of that byte becomes the Y position. So it's that upper half of that byte, but then it multiplies it by the character height. So it does a formula involving multiples of 16 basically, so that based off of the upper and lower halves of the byte, it knows where the exact X and Y position is. And so that's how it automatically knows, no matter which character I call it with, my formula is perfect and it will always do the correct character. Unless, of course, it's completely outside the range of expected characters, but that rarely happens. So then X2 and Y2 are very simple. They're simple variables created to be exactly x1 plus the character width and y2 plus the character height. And then it does this little loop. After it displays where it found the character, it does this very simple loop, while y1 is less than y2 and while x1 is less than x2, it just does that. So it's literally copying row by row from the source of the font bitmap into the destination bitmap. So it actually works. So you see it's increasing the X and Y values, both of the destination and the source, but then it sets the X back to the way it was by subtracting the character width. So that's what it does with those two variables. Meanwhile, the Y, which is the output coordinate for the destination image, and Y1, which is the source coordinate for the input image, the font image, that number just keeps increasing. It doesn't go back to its starting value. So that just increases and it's never sent back. So yeah, basically I can take any character. So let's just say that we wanted to do a certain punctuation mark. Let's look at our font or something. Let's see here, what would I want to do? Let's say that I do the pound sign. That should be an easy one to do. Okay, so let me go back to my function here. If I put the pound sign as my character here, and I can change the position if I like. I can change the position to 200x value for destination, and we will compile and rerun this. And then when we look at the output image, you will see it copied the pound sign, but it's further to the right than it was before. That's because I set a new position for it. But there's our pound sign, or the number sign, or the sharp sign if you're a musician, basically. So that's basically it. It's really cool. Actually, I can flip the image because I'm in image glass. I can do funny stuff like that. But that's just nonsense. So as you can see, my function is capable of loading a single character, but look at all the work it has to do. First, we have to have our variables for our output image, and the global variables are up above at the top of the file. So it fills the image with a certain color, but then it loads the font bitmap. Then it saves the font bitmap just so I can show it to you. And then we have the function that puts a single character at a certain position in my image. So I can output any character. So as you see, it works. It does all of that amazing work, but it's quite a great deal. Now, hopefully, after looking at this, you'll have a great deal of appreciation for all the work that actually goes into displaying characters on the screen, because basically that's it. And also, I just want to show you briefly now, my function that loads bitmaps let's see, let me find where, this is, because when you see that it's loading the font file, it loads a Microsoft bitmap file into memory, so it opens it and it finds what the device independent bitmap size header is, basically, and it gets all the information from the exact addresses where the height and width are stored. And that was all because I learned so much about the format of the Windows bitmap format that I actually wrote my own C standard library function to seek around and read specific values so that I can actually load a Windows bitmap file. Now, I also have the PNG files, but I can't load PNG files because they're compressed. They're much more complicated. I need to use a special library for that. But anyway, you see, that's basically how it works. So now you have seen that I'm capable of outputting text pretty much to anywhere on the screen. Anywhere in the output image, that is. So anyway, I hope you've enjoyed this. See, this is exciting because once I'm capable of outputting a single character to an image with my binary bitmap format, my binary bitmap library that I've been working on for over a year, then all it takes is another function to sequentially call that same function so that I can output strings of text. So that is one of my future goals. The idea is that I could have hello world. I could have hello world. I just thought about something. I totally thought of something. I could have hello world or any sort of text output to the screen, but I just had a brilliant idea. This will make the video a little bit longer, but I just had this inspiration. Now, what would happen? Let's say that what if we load a different font? Because I have other files here. So you see, here's my here's the original size, and there's the PNG file. But I also have bigger sizes. So yeah, that actually works. So let's say, what if I wanted to take let's take the font 32 by 32. Let's see here. I wonder if there's a way to save this. I want to save this file as a different file. Okay, yeah, actually, I know of an easy way to do this. I'm going to go into this folder again. All right. Oh, I need to, because it just occurred to me my function still might work even if the font loaded was original different size. So let's do does the magic command? Yeah, the magic command exists on my system. So I'm going to type magic font font 32 times 32 dot png to font 32 times 32 dot bmp. So now we should have our larger font in the bitmap format here. Very interesting. So now we have 32 by 32 pixels because that image has just been scaled in GIMP. That's the only difference. So let's do a comparison. I really want to see if this works because I did not anticipate doing this when I originally made the video. So let's just take the number 8. Okay, so we'll go back to 100. Let's take the number, or let's take the number 6 here. That'll be our character. So We compile and run this program the way it was, and let's see, we have the character 6 at this position. But let's try loading the larger version of the font. Yeah, let's try this. So if that's what I want to do, then I will simply copy that line. I will comment out this version of the line, and then I will simply change the numbers here, because we're simply loading a different font file that's 32 by 32, and then we change these numbers that we pass to it. Yeah, so 32 width and height. So let's see if this actually works. It should work. There's no logic or reason why it shouldn't work. So, okay, let's see if it works. So it's loading that file for reading, this file here. Now, yeah, the width and height of the file and the size of each character is 30. Yep, trying to output the character position, and it found that character at that position in the bitmap. Okay, let's see. So first, let's look at our font. Our font is copied. The font is correct. Let's go to the next file. It actually works. Now, see how the 6 is bigger now? The 6 is bigger. Oh, I loaded the scaled font, and it actually worked the same. So in other words, I succeeded in my goal. Yeah, I actually succeeded in my goal, because now, simply by taking that original 8 by 8 pixel font and scaling it to be, you know, twice or 4 times as high. Now I loaded one that's exactly 4 times the size, but the proportions are the same, so it works the same. So now I have an 8 by 8 font and a 32 by 32 font. So I can load those fonts into memory, and I can output a single character where I want on the screen. So it'll take a little bit longer to have a put string function, but I know I could do that next time I do my programming, but I'm actually getting really tired now because I just spent another 5 hours on computer programming, so I'm pretty worn out, but it actually worked. My experiment worked, and I can now output I can actually load my own customized bitmap font and output text to the screen. So with text output combined with my existing code that does the spinning polygons and all that sort of stuff with my other code, this means I can create animations involving text, but that do not rely on Allegro, SDL, SFML, or some other graphics library. I can do it entirely with the C standard library and my own collection of files. So I have my own special font, but it's not a font I created. I created the file, but that font exists in Windows. It's existed basically since the DOS days, if I understand it correctly. So I actually can do it. And that's pretty much the same way all the fonts in all the video games are done. You know, back on the NES and Super NES, each game had its own customized font for how it displayed text. So anyway, I'm very excited that it worked, and I hope somebody has learned something about computer programming in this. Because if you're into fonts and graphics and that kind of stuff, this might actually give you ideas. But I've worked on this code for some time, and I'm proud of it. So in the future, I'm going to write my own function that will output a string of text to a certain position on the screen. I think I know how to do it, but I'm tired for now, so maybe another day.